So when you look up into the population of your study, if the population is so big, there might be a problem in the collection of the data that you could not afford to collect the data from the entire members of the population. So the researcher, the data collector, would actually look into the sample of the population. And with sample of the population, we actually look at into representative of the entire population. However, if the researcher, the data collector, has actually the financial resources to collect the data from all members of the population, then that's totally fine. And when the researcher collects the data from the entire members of the population, we call that one as census. So again, census is a data collection from the entire members of the population. However, if the financial resources are limited and that the researcher, the data collector, cannot actually collect the data from the entire members of the population because of financial resources, time resources, and in terms of effort, then you can actually collect the data from the sample. But the sample must be representative of the total population. So later, we'll talk about different sampling designs. So the first topic of chapter 7 is all about hypothesis testing with one sample. Do you see my slide?
Yes, no.
Okay.
Yes, sir.
So
Yes, sir.
these are the chapters.
Yes, sir, yes.
So 7.1, it's all about introduction to hypothesis testing. 7.2, hypothesis testing for the mean, wherein sigma is known. That letter there is Greek letter sigma, and that refers to the standard deviation of the population. The standard deviation of the population. Next is hypothesis testing for the mean. Sigma is unknown. And again, sigma is what we call the standard deviation of the population. It is a Greek letter that represents the standard deviation of the population. 7.4, we'll talk about hypothesis testing for proportions. Then 7.5, we'll be talking about hypothesis testing for variance and the standard deviation. So we'll take up first section 7.1, all about introduction to hypothesis testing. So 7.1, what are the specific objectives? We look up into practical introduction of hypothesis test. How to state a null hypothesis and alternative hypothesis. How to identify type 1 and type 2 errors and interpret the level of significance. How to know whether to use a one-tailed or two-tailed statistical test and find a p-value. How to make and interpret a decision based on the results of a statistical test. Then the last one on the slide, how to write a claim for a hypothesis test. So we have this official definition of statistics. We look up into hypothesis test as a term in hypothesis testing. And what is a hypothesis test? So from the slide that you are seeing, a process that uses sample statistics to test a claim about the value of a population parameter. So it is actually a process of using sample data or sample statistics to test a claim about the value of a population parameter. So our claim is all about the population or the population parameter. And when we say population parameter, these are the characteristics of the entire population of the study. And when we say sample statistics, these are the characteristics of the sample data, and the sample data are taken from the representative of the total population. So take note that the sample is representative of the total population. So in the entire research process, in the entire hypothesis testing, you must know first what is the population of the study, and you must know also the sample or the sample data. That's why we're talking about population parameter and sample statistics. So for example, consider a manufacturer that advertises its new hybrid car has a mean gas mileage of 50 miles per gallon. If you suspect that the mean mileage is not 50 miles per gallon, how could you show that the advertisement is false? So under this case, this one is an example of a consideration that one should actually undergo hypothesis testing. So you will know that this is actually true or this one is actually false once you are going to undergo hypothesis testing. And how do we define a statistical test? When we look at a statistical hypothesis test, it is a statement about a population parameter. It is a declarative statement about a population parameter or a population characteristic. So carefully state a pair of hypotheses. So the hypothesis that we are talking is all about a pair of hypotheses. So take note that basic language hypotheses wherein the last three is SIS. The server that is actually the singular form. And the hypothesis wherein the last three words SES is actually referring to the plural form, no? Hypothesis and hypothesis. So one that represents the claim, and then the other is the complement. So they're actually complementary. So later you will know on what do we mean by complementary statements. When one of these hypotheses is false, the other must be true. Since they're complementary, if the first is true, the second is false. If the first is false, then the complement or the second statement is actually true. So either hypothesis, the null hypothesis or the alternative hypothesis may represent the original claim. So the two kinds of hypotheses that we will be talking are the null hypothesis and then the alternative hypothesis. So in this case, we're talking about the capital letter H that would represent hypothesis. So we look up into the definition of hypothesis. So a null hypothesis, normally represented by HO, is a statistical hypothesis that contains a statement of equality, such as, so these are the equalities, inequalities, equalities, inequalities that are being used in the null hypothesis. So we have less than or equal to. The first one is less than or equal to. Then the second is equality. Then the second is greater than or equal to. So these are the mathematical operations that are found in a null hypothesis. So again, less than or equal to, or it can be equality, or it can be greater than or equal to. So take note that we use the connective or. So that means out of the three, only one is possible. It can be less than or equal to, it can be equality, or it can be greater than or equal to. So we have the HO, or the null hypothesis. The second is what we call alternative hypothesis, represented in this slide as HA. So whenever you encounter HA, that represents alternative hypothesis. But we have some variation. If you are going to read other books in statistics, null hypothesis is HO. The alternative hypothesis is H sub 1. So one book to another book in statistics would have different symbols. In this slide that we are using, in my perspective, we're using HO as null, HA as alternative hypothesis. In some books, null is still HO, but the alternative hypothesis is classified as H sub 1 or H1. And our alternative hypothesis is the complement of the null hypothesis. And it is a statement that must be true if HO is false. And it contains the following mathematical operations. Greater than, not equal to, or less than. So greater than, not equal to, or less than. You will have a better understanding of these two in the examples that will follow after this slide. So HO pronounced as H sub 0, or it can just be HO. We have HA can be read as H sub A, or you can just read that one as HA. So, since we are talking about mathematical operations, then these are actually the different pairs of the complement. So HO is the complement of HA, or HA is the complement of HO. And these two is one pair, one possible pair. Or it can be HO, mu greater than or equal to K. HA, mu is less than K. So this is another possibility. Then another statement, another pair of statements, HO, mu is equal to K. Then HA, mu is not equal to K. Where HO, the null hypothesis, HA, the alternative hypothesis. And then mu is the population mean. So I repeat, mu is the population mean. Mu is a Greek letter. Mu is a Greek letter, and that represents a population mean. And this letter K would represent any value. It is actually any value representing the population mean. So I repeat, these are the following possibilities. When we look at the pairing of alternative hypotheses and null hypotheses, these three are the possible pairs. So we have HO, HA. We have another one, HO and HA. We have another one, HO and HA. But take note, the symbols are different. Regardless of which pair of hypotheses you use, you always assume mu is equal to K. And examine the sampling distribution on the basis of this assumption. Mu is equal to K. So that's our basic assumption. So take note, in statistics, so we look at into basic assumption. And when we say assumption, these are statements believed to be true at the very beginning. And then we have the detailed mathematical symbols and the verbal description. So how are they being written in terms of verbal languages or verbal statements? So at the center, you can find the mathematical statements. To the right of the mathematical statements are actually the verbal statements of the alternative hypotheses in words. And to the left of the mathematical statement are actually the verbal statements of the null hypotheses on how are they stated in words or different statements. Because in some cases, if you're not mathematically inclined, then the mathematical statements at the middle cannot be understood. However, we have to relate this one into words or into statements using the English language. Just a reminder, kindly turn off your microphone. Kindly turn off your microphone. Second warning, and then the next time that you are not mindful of your microphone and you are just a disturbance of the class, I'm going to remove you from the panel. Okay? So all must mute their microphones. Okay? Otherwise, this virtual class will be disturbed by your unmuted microphones. Is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, Doc.
Yes, sir.
I just want to clarify that when you are in the virtual class, everyone must mute their microphones so that the entire session will not be disturbed. And then you can turn on your microphone anytime if you have clarifications. So before I go to the discussion of the slide that you are seeing, I'd like to ask everyone if you have some clarifications.
Nando.
Nando.
And so
None
far,
so
Doc.
far, sir.
Okay, sige. So I discussed already the middle column. These are the three possible pairings of the null hypothesis and the hypothesis which we classify as alternative hypothesis. So in terms of HO, we have mu greater than or equal to K, then mu is less than K. So how are these stated in terms of verbal statements? So it can be greater than or equal to K. It can be at least K, because we say at least K, that means equal to K or greater than K. And when we say not less than K, so not less than K, that means that K is what? Equal to mu, or it can be greater than K. Not shorter than K. So it might be equal to K or maybe what? Longer than K. These are some of the verbal statement of HO found in this mathematical symbol. Next, for the verbal statement of HA in the first pair, this one, mu is less than K. So it can be stated as less than K or below K, fewer than K, or shorter than K. So I repeat, less than K, below K, fewer than K, or shorter than K. These are the variations of this HA, mu is less than K. So we have the second pair. We have HO, mu is less than or equal to K. So what are the equivalent verbal statements? So we have less than or equal to K, at most K. We'll say at most K, the maximum is K and it can have a lower value than K. Not more than K, so that means K or maybe less than what? K. Not longer than K, so it can be K or what? Lower than K or shorter than K. These are the following verbal statements for alternative hypotheses. So the alternative hypothesis, HA mu is greater than K. So what are the different variations of the verbal statements? So greater than K, it can be above K, it can be more than K, or longer than K. And for the third possibility, the third pair, we have HO, mu is equal to K. So it can be equal to K or just K, exactly K, the same as K, then not change from K. No change from K or not change from K. In terms of the alternative hypothesis, we have mu is not equal to K. So what are the different verbal statements? Not equal to K, different from K, not K, different from K, or change from K. So that's the set of possibilities in terms of verbal statements for the alternative hypothesis. Any clarification before I go to the next one?
None, sir.
None,
None,
sir.
sir.
Okay. So we have this example. So state the null and alternative hypothesis given the condition. Write each claim as a mathematical sentence. State the null and alternative hypothesis and identify which represents the claim. When we say claim, we look up into statistics as part of research. When we do research, we have a claim. And that's what we are talking about, the claim to be identified in the following statements. So as a researcher, you must have a claim on what are you going to claim in your research process. And that's what we are talking about, the claim here in the statistical process. So number one, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Now, When the given is in terms of percent, then we look up into proportion. So proportion in statistics, in hypothesis testing, is actually all about percent. So percent, that means per 100. That means 61 over 100 or just 61%. And when the given is a proportion, we're not going to use mu, the Greek letter mu, but we are going to use a small letter p. And that small letter p represents the proportion found in the population. So we have HO and then HA. So it is mentioned is 61%. If you remember your algebra, is a linking verb in English language. And that linking verb is actually represented by equality. So the word is represented by equality. That is why 61% or 0.61. So P is equal to 0.61. But take note that in the preceding, if you are going to have this statement, equality, mu is equal to K, that represents HO. Or mu less than or equal to K, that represents HO also. If HO is mu greater than or equal to K, then that is still HO. And they're actually complementary to each other. This one less than or equal to complementary with greater than. Equality is complementary to not equal to. Since we have mu is equal to K, we label this one as HO. So our HA, mu is not equal to K, following this possibility. I mentioned earlier that of the three possibilities in terms of mathematical statements, out of the three, only one is true in a given setting. So let me go back to this. So we have HO, P is not equal to 0.61. And then HAP is not equal to 0.61. Remember, in the previous slide, the pair of equality is not equal to. So we look at into this setting that we have HOP is equal to 0.61, HAP is not equal to 0.61. And all of these are based on statement number 1. And why we classify HO as the claim? So this one is the claim. Because this one is actually the claim mentioned in number 1. It is actually stated in the given problem. So what is stated in the given problem, what is claimed in the problem, is classified as the claim in terms of the hypothesis. Since we have activity is 61%, and that refers to HO, P is equal to 0.61, then we classify this one as the claim. So we have now the set of hypotheses test being classified as HO and HA. And all of these values are taken from statement number 1 or problem number 1. So before I go to example number 2, I need clarification of example number 1.
And
Sir, good evening, sir.
Yeah, go ahead.
I have a question, sir. Instead of having or using the decimal form of 61%, sir, can we use the 61%, sir, instead of the 0.61?
That's a good question. It can be 0.61 or you can use 61%. Remember, we can write percent in terms of decimal. We can write percent also in terms of that percent symbol. So it does not matter if you are going to write 61% or 0.61. That will be okay,
sir.
Or you can write this one as 61 over 100. That's also correct. So it can be 61%, it can be 0.61, or it can be in terms of fraction, 61 over 100.
Okay, sir. Thank you very much, sir.
Any other clarification? Okay, so if there is none, I go to the next example. So again, you are going to identify the null, an alternative, and identify which represents the claim. So I go to this. So a car dealership announces that the mean time for an oil change is less than 15 minutes. A car dealership announces that the mean time for an oil change is less than 15 minutes. So less than 15 minutes. That is stated here, less than 15 minutes. So it represents what? HA, alternative hypothesis. So how do we know that HA is mu less than 15 minutes? Now this one, less than 15 minutes. Since the given is not in terms of percent, we can now use the Greek letter mu. So I said the Greek letter mu represents the population mean. And if the given is percent, then what you are going to use is small letter p that represents proportion. So how do we know nga this less than 15 minutes should go to HA? So again, we go back to the three possibilities. So let me go back to this slide. Of the three, we have mu less than k. Diba? We have mu less than k. The other one, mu greater than k. The other one is mu is not equal to k. So this is actually found in the given statement, less than k. So we have to use this possibility. HA, mu is less than k. And the complement, HO, mu greater than or equal to. So we'll go back to the example. So we have now mu less than 15 minutes. So our k is 15 minutes. We're not going to use k anymore because we have a specific value of k. And why we are using mu? Because the given is in terms of other units, not in terms of percent. So what is the complement of less than? So it's greater than or equal to. So if you notice, mu greater than or equal to. So take note, less than. Now this less than. So the complement is what? Greater than or equal to. So we have here greater than or equal to is the complement of less than. The complement of less than is greater than or equal to. So we have now mu greater than or equal to 15 minutes. So we have now stated HO and then HA. So next is to identify the claim. So the one mentioned in the problem is actually the claim. So it is stated, a car dealership announces that the mean time for an oil change is less than 15 minutes. So this one is reflected in HA, the alternative hypothesis. So mu less than 15 minutes. So we classify alternative hypothesis as that. So before I go to the next example, any clarification?
None, Doc.
None po.
How about the rest? Any clarification?
None po.
No, Doc.
There is none.
None po,
Then
Doc.
I'll go to the
None, Doc.
So third example. Could anyone read example number 3?
Ako, Doc.
Okay, go ahead.
Okay. A company advertises that the mean life of its furnaces is more than 18 years.
Okay. So as a classwork based on example number 1 and number 2, so kindly state HO and then HA and then identify the claim.
Okay,
Once
Doc.
you have identified HO and HA, and then you're going to identify the claim. That's for everyone. No? So write your answer on a piece of paper. Write first the problem, and then once you have written the problem, you're going to write HO and HA and identify the claim. After that, take a picture and then upload that one into the stream of our Google Classroom. So that's classwork number 1. I'd like you to write HO and HA, but write first the problem, and then write HO, write HA, and then identify the claim. So I'll give you 10 minutes to do that.
Sa papabigsa mo. Sir, hindi na siya connect. Connect.
Sir?
Nandok.
Sir.
Go ahead.
Sir, pwede na ako makita itong slide, itong na yung mga kuan, sir, of mathematical sentence, sir?
That one.
Okay, sir. Thank you, sir.
You're welcome. Okay. Just take a picture of that slide for your guide, and then I'll go back to the classroom. Done taking picture of this slide?
Done, sir. Thank you.
Okay, you're welcome. That's example number 2. And this one, for example number 1, if you have not taken a picture, so you can take a picture of example number 1. And then you can take a picture of example number 2.
Excuse me, sir.
Go ahead.
Where can we send the photo?
Google Classroom stream of the Google Classroom.
Okay, sir. Thank you.
Okay. So all your answer must be uploaded to the stream of our Google Classroom. So take a picture of your answers and then upload that one into the stream of our Google Classroom. Once you are done, upload your output into the stream of our Google Classroom.
Yes, sir. Done.
Okay, and then I'll stop sharing first, and I want to have a volunteer to share his or her output. Only one volunteer. So I stop already my screen sharing. Okay, Miss Claudie, you can go. Go to screen sharing. Claudie, no? Is that you,
Yep.
Claudie?
Yes, sir. Cloudy.
Claudie ba? Claudie?
Cloudy, sir.
Claudie. Okay, sorry for that. Claudie, go ahead.
Okay, Doc. Doc, okay lang ug basahon lang nako, Doc?
Okay, go ahead.
Okay. Let me read first the mathematical statement. A company advertises that the mean life of its furnaces is more than 18 years. So here is my solution. The null hypothesis, mu is less than or equal to 18 years. It is the complement of the alternative hypothesis. While the alternative hypothesis, it is mu greater than 18 years. It is the claim or the inequality condition. So that's it, sir.
Okay. Thank you, Claudie. I need another one that can share the output. After Claudie, I need one more for a visual presentation. So a while ago, it's actually an audio presentation. Now I need to have a visual presentation of your output. Any volunteer? You can just share directly your output. Those who would like to volunteer. Anyone? Hello? Okay, Kashmir, you're raising your hand, so you'd like to volunteer? Kashmir? Okay, go ahead, Kashmir. Or if not, Reven, Mylon.
Yes, sir, okay.
Okay, sige, go ahead.
A company, the problem is a company advertises that the mean life of its furnaces is more than 18 years. So solution, my claim is HA mu is greater than 18 years and the complement of HA is the HO mu is less than or equal to 18 years.
Okay, so thank you very much. So could you stop sharing na? Okay, so do you see my screen?
Yes, no.
Okay. Okay, so we have this one as answer of number 3. Mu is greater than 18 years. And then the next one is mu less than or equal to 18 years. And the complement, HA, mu is greater than 18 years is less than or equal to. So remember, they are actually complementary based on the given 3 possibilities. And since it is stated in the problem is more than 18 years, more than means greater than. So we have mu greater than 18 years. And since this one is the one stated in the given problem, then we classify alternative hypotheses as the. So next we have the visual representation of HA and then HO. So in number 1, we have here HO 0.61. It is stated that mu is equal to 0.61. In the second example, we have the HO is actually here. This one, we have equal to 15 minutes or greater than 15 minutes. That's HO. If you look at this arrow, the black one, we have greater than 15 or less than 15. And then the third one, HO. So we have HO less than 18 or equal to 18. And in terms of the representation of alternative hypotheses, so we have HA, it's actually less than or less than 0.61. Remember that the line does not include 0.61, so it's less than 0.61. And then the other example, number 2, HA, or the alternative hypothesis, it's actually less than 15. So we have this blue line going to the left side, and this means less than 15. And then number 3, we have HA alternative hypothesis. The blue line is greater than 18. So we have greater than 18 represented by the alternative hypothesis. So we just have this visual representation to have a better picture or a clear picture on what is HA and what is HO. How do we represent that one in terms of visual or graphical presentation? So next is type of errors. So before I go to type of errors, any clarification on how to write HO, how to write HA, and how to identify the claim based on HO and HA and based on the given statement of the problem?
None, sir.
None, Doc.
None, sir.
None, sir.
Okay, So even if you're equipped with the knowledge and skills of statistics or even research methodologies, all are bound to commit errors. Errors are always there. There is no such thing as a perfect statistical test. There is no such thing as a perfect research findings, but all have errors. So the first bullet, no matter which hypothesis represents the claim, always begin the hypothesis test assuming that the equality condition in the null hypothesis is true. That is why if you're going to read the thesis or dissertation, the hypothesis that is normally used or actually used in any kind of research, in any kind of thesis, or in any kind of dissertation is HO or the null hypothesis. So when you perform a hypothesis test, one of two decisions will be made. So you reject the null hypothesis or you fail to reject the null hypothesis. Actually, number two, it can be stated as accept the null hypothesis. But in terms of the statistical process, we normally consider fail to reject the null hypothesis instead of saying accept the null hypothesis. But the right term in statistics is fail to reject the null hypothesis. Do you follow? So as mentioned,
Yes.
fail to reject the null hypothesis. That is actually the term. Some books are actually using that term reject the null hypothesis. But we have the term reject the null hypothesis that must be coupled with fail to reject the null hypothesis. But some books you can find also, especially Filipino authored books, accept the null hypothesis. And you can find this one also in many theses, in many dissertations, that what are being used is accept the null hypothesis. But to be exact, in terms of statistics, the right term is reject the null hypothesis. Then the second one is fail to reject the null hypothesis. I'm going to repeat this one for emphasis. The right term is reject the null hypothesis, then fail to reject the null hypothesis. Even if most literature, if not some literature, are telling the number two is actually accept the null hypothesis. But in the community of statisticians, the term used is fail to reject the null hypothesis, not accept the null hypothesis. So take note of that. Because your decision is based on a sample, there is the possibility of making the wrong decision. So take note that we do hypothesis testing because we collect data from the sample. We cannot use hypothesis testing if you collect the data from the entire population. Remember, when we collect the entire data from the entire population, that's what we call census. So census is the collection of data from all members of the population. However, if you collect the data from the sample of the population, then you actually do a survey. A survey is a collection of data from the sample, and that sample is considered representative of the entire population. I repeat for emphasis that if you do survey, then you can use hypothesis testing. But if you do a census, you cannot use hypothesis testing because hypothesis testing is only based on a sample. And you cannot use that one if you do a census or collection of data from the entire population. What you have collected from the entire population is the one that you can conclude. However, if you collect the data from the sample, then you need to find a consideration, that's what we call hypothesis testing, to verify that what you have collected from the data can be generalized to the population where the sample is actually taken. So I repeat, the purpose of hypothesis testing is to generalize that whatever truth that you have found in the sample, you are going to verify that one if that is also true in the population where the sample is actually taken. You're going to ask, is this true also to the population where the sample is actually taken? Because there might be a possibility that that's only true in the sample, but it does not have truthfulness or reality in the population where the sample is actually taken. There might be possibilities that it is true in the sample and not true to the entire population. There might be a possibility not true in the sample and true also to the population where the sample is actually taken. And that's the nature of hypothesis testing. I repeat, you can only do hypothesis testing if you use sample data. However, if you have a census, you do a census, then no for hypothesis testing. So these are the possible outcomes for type of errors. So there are two types of errors. We have type 1 and then type 2. So if you look at this table and you need to memorize the concepts so that later when we have different exercises, you can actually have a better understanding. And according to all of you are teachers, so according to the revised version of the cognitive domain, we have 6 stages of learning. So we have remembering, understanding, applying, analyzing, evaluating, and then creating. And stage 1 of learning is remembering or the memorization. That is a lower order thinking skill, but that is mandatory so that you can go into higher order thinking skills. So we have 2 decisions. Do not reject HO. That means fail to reject HO, or do not reject HO, then reject HO. Remember in the previous slide, there are 2 decisions that you are going to make. Reject HO or fail to reject HO. When I say fail to reject HO, that means do not reject HO. But in reality, all of you have taken logic. The hypothesis is actually a declarative statement. And if it is a declarative statement, then it can be true or it can be false. In our logic classes, in our basic philosophy in terms of logic, there are 2 classifications of a declarative statement. It can be true or it can be false. So our actual truth for our null hypothesis can be true or false. So HO can be true or HO can be false. Now, in terms of decision, you do not reject HO because HO is true. Then you made a correct decision. Because in research, if that is true, then you have to accept that one. You do not reject HO because HO is true. Then you made a correct decision. Next, if you reject HO, you reject HO. But what is the reality of HO? HO is false. So HO is false. And your decision, you reject HO. And why do you reject HO? Because HO is false. Since HO is false, then you have to reject HO. Because in research, what is true is accepted. What is false is rejected. Then you made a correct decision. If you reject HO, then HO is actually false. So there are 2 types of correct decision. You do not reject HO because HO is true. That's a correct decision. You reject HO because HO is false. Then that's a correct decision. However, no one is perfect. Then there might be rejection of HO even if HO is true. So if you reject HO, in fact, HO is true, we classify this one as type 1 error. So type 1 error occurs if the null hypothesis is rejected when it is true, or a true null hypothesis is actually rejected. Then we have type 2 error. The type 2 error is actually referring to HO is false and you do not reject HO. You do not reject HO even if HO is false. So we classify this one as type 2 error. So a type 2 error occurs if the null hypothesis, if the null hypothesis is not rejected when it is false. So be able to classify what is type 1 error, what is type 2 error, what is a correct decision, what are the two statements that would lead to correct decision. So any clarification before I go to the next slide?
Answer.
Answer.
Okay, thank you. So I'll go to the example. Any volunteer to read the example on the slide? Hello? Any volunteer?
Can I do, sir?
Yeah, go ahead.
Okay. Example 1, identifying type 1 and type 2 errors. The USDA limit for salmonella contamination for ground beef is 7.5%. A meat inspector reports that the ground beef produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur? Which error is more serious?
Okay, thank you so much. So we look up into this example. We say the USDA limit for salmonella contamination for ground beef is 7.5%. So what kind of mathematical operation are you going to consider? From the statement, the USDA limit for salmonella contamination for ground beef is 7.5%. Are you going to, what kind of mathematical operation? So in the previous slides, I mentioned already mathematical operation. So what kind of mathematical operation? Mark, you're raising your hand. Would you like to answer?
Okay, from the statement itself, that is a salmonella contamination for ground beef is, the linking verb is, that is equal to the mathematical expression that is equal.
Okay, you said equality, no? Equality.
Yes.
Any other answer aside from equality? Mark is telling us about equality. But how about other answers? So Mark mentioned about equality. If you would like to answer, just unmute your microphone and tell me the answer directly. I'm sharing my slide. I cannot see actually who are actually raising their hands.
Excuse me, sir. It's Estrada, sir. I believe it's we use the mathematical expression less than or equal to 7.5% because it said it's the limit, so you will not exceed to that amount.
Okay, yeah, I agree. Although Mark is correct, but said is, and that linking verb is equality. But remember in the statement, there is what we call the USDA limit for salmonella contamination for ground beef is 7.5%. So because of the word limit, that means the maximum is 7.5. And it can be lower than 7.5 because we have the statement, the USDA limit for salmonella contamination is 7.5. So that means it should not exceed 7.5. The maximum value is 7.5%. And it can go lower because of the term limit. So it must not go beyond 7.5%. And take note that we have different mathematical statements, and there are actually corresponding verbal statements. So it must be less than or equal to 7.5%. So if we're going to look up into, so we have there greater than 0.75, and we have less than or equal to 0.075. So HO, we have P is less than or equal to 0.075, or that can be 7.5%. If you don't like the decimal, you can write it as 7.5%. And then the complement, alternative hypothesis, P greater than 0.075. So we have 7.5%, greater than 7.5%. Mr. Palubon, you're raising your hand. Go ahead.
Wala, sir.
Okay, sige. So we have here HO and then HA. So take note that the one that is being claimed is P greater than 0.075. And why we are using P? Because the given data is in terms of percent, not in terms of any other value. It is mentioned in there. Meat inspector reports that the ground beef produced by a company exceeds the USDA limit. So that's the claim. And then you are going to perform a hypothesis test. Okay, so these are our hypotheses, HO and then HE. And we know already that the claim is the alternative hypothesis. So in terms of visual representation, so we have now the graphical method, HAP greater than 0.075. So we have now 0.075, the blue line is referring to HA, that's a P greater than 0.075. And we have the black line going to the left side, P less than 0.075, but we have equality. So the 0.075 is actually included. So this number line is showing about the visual representation of our HO and our HA. So the next one is to have the HO and the HA in terms of type 1 error and type 2 error. So when type 1 error occur, so a type 1 error occur if we have a type 1 error is rejecting a true null hypothesis. That's our definition. So we look at the definition. A type 1 error is rejecting HO when it is true, or you reject a true null hypothesis. And when can a type 1 error occur? So the actual proportion of contaminated ground beef is less than or equal to 0.75, but you reject HO. So HO is true. And what is HO? The actual proportion of contaminated ground beef is less than or equal to 0.075, but you reject it. So that's our type 1. Because our definition of type 1 error, you reject a true null hypothesis. So if HO is true, we say actual proportion. That means the reality, that's the truth. The actual proportion of contaminated chicken or beef is less than or equal to 0.075. So we have 0.075, less than or equal to. This is true, but you reject HO. So that's type 1. Now type 2. How do we define type 2 error? So type 2 error is failing to reject HO when it is false. You do not reject HO when it is actually false. So the actual proportion of contaminated ground beef is greater than 0.075, but you do not reject HO. So the actual proportion of contaminated ground beef is greater than 0.075, but you do not reject HO. So this is our type 2 error. How do we define type 2 error? We define type 2 as you do not reject HO even if HO is false. You fail to reject HO even if HO is false. So that's type 2. So any clarification for this example? Why do we have type 1 and why do we have type 2? And in this specific example, this is our type 1 error and this is our type 2 error. So any clarification about these statements? If you have some clarifications, just open your microphone, unmute your microphone, and raise directly your clarification. Hello?
None, Doc.
Okay.
Wala po, sir.
Okay. So I'd like you to have another classwork. So the other classwork is of the type 1 and type 2 error. Which one is more serious? Diba? In the previous slide, diba? Which one is more serious? Si type 1 or type 2? In reality, you know already type 1 and you know type 2 based on the given statement. Then, of the two, which one is more serious? So, and why? Justify why it is actually a more serious error. And then, screenshot your answer. I'm going to create a classwork and then upload your answer to the classwork. Okay, so take note, it's not in the stream, but I am creating a classwork where to upload your answer. So go ahead, decide on which one is more serious. Is it type 1 or type 2? And justify your answer. I'll give you 10 minutes to do that. So I have created already the classwork. The classwork is October 21 classwork. So October 21 classwork. So just upload that one in your respective Google Classroom. So you have 15 minutes to do that. Decide on whether it is type 1 or type 2 error.
Excuse me, sir. Do we still have to handwritten it or encode and screenshot?
Just handwrite it on, then take a picture.
Okay,
If you like
sir,
to
thank
encode
you.
it one, I did not have a specification. You can encode it one, or you can actually handwrite it.
Thank you, sir.
Bahala na siya. Ay, sabot. Isa ka. Pagkuan. Ako kasabot. No. Binong dito, wala para bukat. Right? Wala man na ipasa na mo. Ipasa pa. Sa chapter 7 man na, chapter 5 lang taman. Ang chapter 6, ganyan.
Ma'am, nabungog ka naman, ma'am.
Chapter 6.
Okay, so let's look at the answer. No? So we have type 1 and then type 2. So the seat work or the classwork is all about which one is more serious, type 1 or type 2. So what is your answer? Which one is more serious, type 1 or type 2?
For me, sir, it's type 2.
So some type 1, some
Type 2, sir.
Type 1 daw.
Type 1.
Type 1, sir.
type 1 and some type 2. No, let's look at the justification. Okay, so I'll show directly the answer. So we have there, with a type 1 error, so looking at type 1 error, you might create a health scare and hurt the sales of ground beef producers who were actually meeting the USDA limit. So again, if you look at type 1 is rejecting a true null hypothesis. The actual proportion of contaminated ground beef is less than or equal to 0.075, but you reject HO. And if you look at type 1 error, the statement is you might create a health scare and hurt the sales of ground beef producers who were actually meeting the USDA limits, at most 0.75 or at most 7.5%. With type 2 error, you could be allowing ground beef that exceeded the USDA contamination limit to be sold to consumers. Why? Because according to type 2 error, a type 2 error occurs when you fail to reject HO when it is false, and the actual proportion of contaminated ground beef is greater than 0.75. The reality is greater than 0.75 or 7.5%, but you do not reject HO. If you do not reject HO or you fail to reject HO, that means you accept HO. So, according to this statement, look at this statement, with type 2 error, you could be allowing ground beef that exceeded the USDA contamination limit to be sold to consumers. Why it is being sold to consumers? Because it is being advised that it is not actually rejected, even if the salmonella contamination is greater than 7.5%. So of the two conditions, which one is more serious? So type 2 error is more serious because it results in sickness or even death. Why? Because meat being produced with salmonella contamination is greater than 7.5%. And that kind of hypothesis is actually not being rejected. Fail to reject HO, or you do not reject HO. So what happens? It is being sold in the market even if the salmonella contamination is greater than 7.5%. So that's the justification. So if you're not able to get the correct answer, I'd like you to read again the process. I'm going to upload this one after our session this evening. Okay, so let's go to level of significance. So level of significance is very common in all types of research. Maybe you have read a thesis already, or in your undergraduate level, you have taken research methods for undergraduate. You have written a thesis, and then there is what we call level of significance or significance level. And the common symbol for level of significance or significance level is alpha. So we say Greek letter alpha, that means level of significance. Or it can be significance level in some books, but in some books level of significance. And how do we define level of significance? So maximum allowable probability of making a type 1 error. What is type 1 error? you reject a true null hypothesis. Type 1 error, you reject a true null hypothesis. And level of significance or significance level is the maximum allowable probability of making a type 1 error. In the common values of alpha or the common values of significance level, we have alpha 0.10, alpha is equal to 0.05, or alpha is equal to 0.01. These are the common values. But in terms of the social sciences, like in education, the common level of significance or significance level is alpha 0.05. So if you review thesis and dissertation in the social sciences or in education, the common value of alpha is 0.0. Then we do have statistical tests. We have different statistical tests, like we have Z, small letter Z, which represents Z-test. Then T, small letter T, which represents T-test. We have this one. I think the symbol is not actually clear, but that refers to chi-square. The spelling of chi-square is C-H-I, then square, S-Q-U-A-R-E. Chi-square, the spelling of chi, C-H-I. C-H-I, then square, S-Q-U-A-R-E. So that's not chi-square, but that is chi-square. Chi-square. So these are the common. We have Z-test, T-test, and then we have chi-square. But later we have so many other types of. So we look at this one, common symbols. No? When we look at population parameter, this can be used if you collect the data from the population. The test statistic can be used if you collect the data from the sample. So this one, if the data are collected from the sample, the test statistic, the population parameter is actually used for data collected from the entire population. If you do a census, you use population parameter. If you do a survey, you collect the data from the sample, then you're going to use test statistic. So mu, as what I mentioned earlier, mu refers to population parameter. X bar refers to sample statistic. Not statistic, sample statistic, X bar. So this is actually the mean of the sample. X bar, the mean of the sample. Mu, the mean of the population. We have then small letter p, so population parameter. This refers to proportion. I mentioned this one in the examples given in the previous slides. This one is p hat. So there is a hat on top of small letter p. And this refers to test statistic. And you can use this as sample proportion. This one, population proportion. Small letter p, population proportion. The p hat is the sample proportion. And then I mentioned about this one, sigma. This is a Greek letter sigma. So chi-square, this is actually sigma square. This refers to the population variance. So small, this is actually a Greek letter. It looks like letter O, but that's not letter O. And it's not Q also. This is a Greek letter which represents sigma, sigma square. This refers to population variance. No? Population variance. And small letter s raised to the second, or s square, is the sample variance. So sample variance is square. Sigma square is the population variance. Earlier, in the previous slide, I mentioned about Greek letter sigma. Sigma alone would refer to population standard deviation. I repeat, sigma alone would refer to population standard deviation. And then s square, or small letter s raised to the second, is the sample variance. S alone is actually the sample standard deviation. So S sample standard deviation. I repeat, small letter S, sample standard deviation. If you have S square, that means sample variance. If you have sigma, that refers to population variance. If you have sigma to the second, that refers to population variance. Then we have standardized test. So I mentioned this one, small letter Z, which represents the Z test. Small letter T represents the T test. Then we have also small letter Z. Then this one is the Greek letter chi. It looks like letter X in the English alphabet. But if you notice how to write X, and this Greek letter chi is totally different. Take note that it's not actually a straight bar, but there is a variation between Greek letter chi and the English letter X. And this is pronounced as chi square. This is a chi square, but it is pronounced as chi square. This symbol, this letter looks like letter X, is actually CHI in the Greek alphabet. And that is pronounced as chi. CHI, chi. Since we have exponent 2, so we have chi square. Chi square. So I repeat, mu, population standard deviation, X bar, sample standard deviation, P, population proportion, P hat, sample proportion. Sigma raised to the second, or sigma to the second, sigma square is the population variance, S to the second, or S square, sample variance. If you have only sigma, just the Greek letter sigma, that refers to population standard deviation. Small letter S alone, small letter S alone. Small letter S, that refers to sample standard deviation. Next is the p-value. So when you use the megastat, and later we'll talk about the SPSS, we are actually talking about the p-value. This p-value is generated by megastat, and if you use SPSS, this one is also generated. P-value, or the probability value. And the common value of P is alpha 0.05, or the p-value could be 0.10, or we have then 0.01, 0.002, depending on the statistical process. And the p-value is generated automatically using a software. But we have also some manual computation of the p-values, which we will not take up because for now, we're going to use technology. So in our statistics class, we have to make use of technology. So the first one that I introduced is Megastat. Later, we're going to take SPSS, or the statistical package for the social sciences. Ang SPSS is a statistical package for the social sciences. Then we go to the nature of the test. When you look at nature of the test, we have 3 types. We have left-tailed test, right-tailed test. We have then the two-tailed test. The type of test depends on the region of the sampling distribution that favors a rejection of HO. And this region is indicated by alternative hypotheses. So when can we decide na it is a left-tailed test or a right-tailed test or a two-tailed test? That is actually based on the alternative hypothesis. So our basis is alternative hypothesis. Pag left-tailed, right-tailed, or two-tailed test, our basis again is the alternative hypothesis. I repeat for emphasis. When we decide on whether it is a left-tailed test, a right-tailed test, or a two-tailed test, our basis is the alternative hypothesis. So we'll have this example. The alternative hypothesis HA is less than. So if you look at HA, mu is less than K. If you're going to graph this one in terms of a normal distribution, less than K This is the value of K less than is going to the left side. And this blue area is what we mean by mu less than K. Since this is actually in the left side, we classify this one as left tailed test. Why left? Because the area shaded by blue, which represents the alternative hypothesis, mu less than K, is situated in the left side. Then the next one, the alternative hypothesis HA contains the greater than inequality. So you have greater than inequality. As I mentioned earlier, our basis is the alternative hypothesis. So if you look at the alternative hypothesis, mu greater than K. So if mu is greater than K, you look at the graph, this one is actually referring to mu greater than K, the shaded area. We have the blue area. And this actually the value of K greater than K is to the right side. That's why it is a right-tailed test. Because the shaded area is going to the right based on the alternative hypothesis, then we classify this one as a right-tailed test. Then we have the two-tailed test. Again, our basis is the alternative hypothesis. So when we look at the alternative hypothesis, look at this alternative hypothesis, mu is not equal to K. So mu is not equal to K. If mu is not equal to K, then it can be less than K or it can be greater than K because it is mentioned mu is not equal to K. If it is not equal to K, so basically our logical analysis would actually think about it can be not K is less than K. So K is less than or K is greater than. So mu can be less than K or mu can be greater than K. So this is actually going to the left and this one is going to the right side. It is mentioned in here. The area to the right of the positive standardized test statistic is 1/2 of P. So why we divide the P by 1/2? Because one is located in the right and the other one is located in the left side. So we have 1/2 of P and the other one is 1/2 of P. So why we classify this one as two-tailed? Because one is in the left side and one is in the right side. That's why we classify this one as two-tailed test, meaning it has two directions. One is going to the right and the other one is going to the left side. So again, for emphasis, our basis of classifying as to left-tailed, right-tailed, or two-tailed is the alternative hypothesis. If the alternative hypothesis is using less than, so it is left-tailed, it's going to the left. If the hypothesis which we classify as alternative hypothesis is going to the right side, then it is a right-tailed test. If the alternative hypothesis is using not equal to, so that means it has to be divided into two. So one is going to the left and the one is going to the right side. That's why we classify that one as two-tailed test. But then again, our point of reference is the alternative hypothesis. So we have identifying the nature of a test. So given the previous example, so we have taken that one in the previous example about a school publicizes. Under this example, we have formulated already the alternative, the null, and then the claim. So now we go back to this example and classify on whether it is what, one-tailed or two-tailed test. It's identifying the nature of a test. So we can classify this. Look at our HA. P is not equal to 0.61. We use not equal to. That means one is going to the left and the other one is going to the right side. So we classify this one as a two-tailed test. The next example, car dealership. We are able to formulate already HO and HA, and we have identified already the claim. So now we go into the nature of the test. So These are our HO and HA. We have our null and our alternative. And then in terms of the graph, we have alternative hypothesis is using less than. That is why we have less than is actually going to the left side. So this kind of test is left-tailed hypothesis test. Then the third example is all about a company advertises that the mean life of its
What if a driver? Okay, next, number 5.
A company advertises that the mean life of its furnaces is more than 18 years. So in the previous slides, we have formulated already the null and then the alternative hypothesis.
But you say chef. It's a chef. Okay, chef. Okay.
I told you already, if you are disturbing my virtual presentation, you are not mindful of your microphone, I'm going to remove you. Okay? I mentioned that one. So all the time, be mindful of your microphone if you don't want to be removed from the panel. So in terms of the formulated HA, mu is greater than 18 years. So we have greater than, that's going to the right side. So this kind of hypothesis test is actually right-tailed test. So again, our basis of saying left-tailed, right-tailed, or two-tailed is the alternative hypothesis. If the alternative hypothesis is using less than, so left-tailed. If the alternative hypothesis is using greater than, right-tailed. If the hypothesis, which we classify alternative hypothesis, is using not equal to, then we have to make use of the two-tailed test. It can be in the left or it can be in the right side. And how are we going to make the decision? So as I mentioned earlier, that at the end of the hypothesis test, you are going to reject HO or fail to reject HO. So reject HO or fail to reject HO. So we have two templates. If the p-value is less than or equal to alpha, then reject HO. If the p-value is greater than alpha, then fail to reject HO. So again, capital letter P would mean p-value. And we have, if the p-value is less than or equal to alpha, then reject HO. The p-value is generated automatically by the computer software. It can be Megastat, which you have downloaded. And later, we'll talk about SPSS. And when I say SPSS, that means Statistical Package for the Social Sciences. So if the p-value greater than alpha, then fail to reject HO. Alpha means the maximum probability of committing type 1 error. And I mentioned already that the common values of alpha, 0.10, 0.05, or 0.01. But in the social sciences, the common value is 0.05. And that's the reason why most of the theses, most of the dissertations are actually having an alpha value or level of significance or significance level that is 0.05. And again, the p-value is generated by Megastat SPSS automatically. The alpha value is set by the researcher. So if you're the one doing the research, if you're the one doing the statistical test, you are going to decide first on what are you going to use, alpha 0.10, alpha 0.01, or alpha is equal to 0.05. But I mentioned that in the social sciences, like in education, the common value is 0.05. So the next one is all about the template on how are you going to make your interpretation based on the decision. So when we say decision, that refers to whether you reject HO or fail to reject HO. The other variation of fail to reject HO is do not reject HO. So it can be fail to reject HO, do not reject HO. The other one is reject HO. So this is the template, the decision. So as I mentioned earlier, there are two major decisions, reject HO or fail to reject HO. So HO, the claim is HO. Diba? In the previous slides, earlier I mentioned that you're going to identify which one is the claim. Is it HO or is it HA? If the claim is HO, then we have this template in the second column. Then if the claim is HA, we have this template in the last column. And the first column is all about the decision. There are two major decisions, as I mentioned earlier, reject HO or fail to reject HO. The other variation of fail to reject HO is do not reject HO. So if you reject HO, the claim is also HO, then your interpretation would be there is enough evidence to reject the claim. So that is the template that is to be repeated when you are going to make the decision. There is enough evidence to reject the claim. Now, if you reject HO, but the claim is HA, then you're going to say there is enough evidence to support the claim. There is enough evidence to support the claim. And then the other decision, fail to reject HO. If you fail to reject HO, there is not enough evidence to reject the claim. There is not enough evidence to reject the claim. And then if you fail to reject HO, the claim is HA or the alternative hypothesis, then you're going to say there is not enough evidence to support the claim. It is very important that you are going to memorize the basic concepts and the different steps to be followed in hypothesis testing. So from the first slide up to this slide, so it is mandatory that you are going to memorize because you will be finding a difficulty when you are going to have a statistical analysis. So here's an example, interpreting a decision. So we have, you perform a hypothesis test for the following claim. How should you interpret your decision if you reject HO? If you fail to reject HO. So we have the first example. HO is the claim. HO is the claim. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So here's the answer. The claim is represented by HO. So if you reject HO, you should conclude there is enough evidence to reject the school's claim that the proportion of students who are involved in at least one extracurricular activity is 61%. So why? Because if we go back to the template, so look at the template, reject HO. The claim is HO. This is our verbal interpretation. If you reject HO, the claim is HA. You're going to say there is enough evidence to support the claim. Then if you fail to reject HO, there is not enough evidence to reject the claim. If you fail to reject HO, the claim is HA, then the template, there is not enough evidence to support the claim. You have to mention first, there is not enough evidence to support the claim, and then the claim, mention the claim based on the statement of the problem. This one is a template. there is not enough evidence to reject the claim. So the claim must be mentioned based on the stated problem. This one, reject HO, the claim is HO. You're going to write there is enough evidence to reject the claim, but in here, the claim must be based on the problem statement. You reject HO, the claim is HA, there is enough evidence to support the claim and state the claim based on the problem statement. So it is easier to memorize. Reject HO, common, there is enough evidence to, there is enough evidence to. HO is the claim, so reject. HA is the claim, support the claim. Then in terms of failing to reject HO, common, there is not enough evidence. This one, there is not enough evidence. But if HO is the claim, to reject the claim. If HA is the claim, to support the claim. So these are actually the templates to be followed and must be followed at all times. The other variation for this case is that enough evidence is being replaced by sufficient evidence. It can be enough evidence or sufficient evidence. This one, enough evidence, can be written in terms of sufficient evidence. There is not enough evidence to reject the claim. Enough can be replaced by sufficient evidence. Not enough, you can replace this one by sufficient. So you can just say there is not sufficient evidence to support the claim. There is no sufficient evidence to reject the claim. There is no sufficient evidence to support the claim. So take note of the process. So let's go back to this one. So where do we get there is enough evidence to reject? So from the template, there is not enough evidence to reject. And then state the claim. So what is the claim? That the proportion of students who are involved in at least one extracurricular activity is 61%. So take note that the claim is HO. So the claim is HO at the very beginning. I'm going to repeat for emphasis. HO is the claim. And then the scenario, the claim is represented by HO. And then if you reject HO, so you reject HO, the claim is HO. So you are going to mention this one. Look at this template. The claim is HO, you reject HO. The template is there is enough evidence to reject the claim. So we have stated here, there is enough evidence to reject. Where did we get this one? From the template under reject HO and the claim is HO. Next example is if you fail to reject HO, the same condition, you fail to reject HO, but still the claim is HO. So you have this one. Go back to the template. The claim is still HO, but you fail to reject HO. So our template, there is not enough evidence to reject the claim. So if we go back to this statement here, fail to reject HO, the claim is HO. So from the template, there is not enough evidence to reject. And then write the claim. So the schools claim that the proportion of students who are involved in at least one extracurricular activity is 61%. Next example. You perform a hypothesis test for the following claim. So again, the claim is HA. So claim is HA. And then we have already this in the previous slides. You remember? We have this statement. For a moment. Okay. So HO is the claim. Take note, HO is the claim. The mean time for an oil change is greater than or equal to 15 minutes. So if you look back into the next, if you reject HO, Where did you get there is enough evidence to support the dealership? That's actually from the template. You reject HO. So if you reject HO, we have the template, there is enough evidence to support the claim. And state the claim. What is the claim? The dealership's claim that the mean time for an oil change is less than 15 minutes. Now, if you fail to reject HO, then you're going to follow the template. There is not enough evidence to support the claim. So remember that it is stated in here. The claim is HA. So if we go back to the template, and go back to the template for emphasis. Go back to the template design. The claim is HA. The first is reject HO. So our template, there is enough evidence to support the claim. The second one is fail to reject HO. There is not enough evidence to support the claim. So let's go back to that example. The claim is HA. So we reject HO. Where did we get there is enough evidence to support the dealership's claim? From the template. And state the dealership's claim. If you fail to reject HO, where did we get there is not enough evidence to support? This is from the template. Reject HO. The claim is the alternative hypothesis. Then to support the dealership's claim that the mean time for an oil change is less than 15 minutes. Okay, so this is the summary for hypothesis testing. The first one is state HO and then state HA. Specify the level of significance. The level of significance is commonly what? 0.10, 0.05, or 0.01. But in the social sciences, like in education, the common is 0.05. Then we can actually construct a graph. So you can manually construct a graph and then calculate the test statistic. So under this case, we'll be using Megastat for the meantime. And then later, we are going to make use of SPSS. Then the next one is all about the p-value. So find the p-value. The p-value can be generated directly by Megastat or the SPSS. Although there is a manual process of calculating the p-value, but we are going to make use of SPSS or the Megastat. So if the p-value is less than or equal to the level of significance, reject HO. But if the p-value is greater than the level of significance, fail to reject HO. Then write a statement to interpret the decision in the context of the original claim. So this number 7 is using the template about there is enough evidence, there is not enough evidence to support the claim or to reject the claim based on the template. So overall, when you look at the steps for hypothesis testing, there are 7 steps. So I'd like to repeat for emphasis. Number 1 is all about stating the claim mathematically and verbally about HO and HA, and then identifying which one is the claim. Is it HO or is it HA? Number 2, you are going to set the alpha level or the level of significance or the significance level. Since we are all in the education unit, so alpha is equal to 0.05. Number 3, determine the standardized sampling distribution. So you can draw this one manually. But if we're going to use technology, number 4 will be replaced by an automated value of the p-value. And then number 5, we're going to find the p-value. The p-value is generated automatically by Megastat or maybe the SPSS. And number 6 is on the decision. So the decision is to reject HO or fail to reject HO. And then the last one is all about making an interpretation of the decision. And that's the same to the example that I mentioned about the different processes of interpreting based on the template about there is enough evidence, there is not enough evidence to support the claim or to reject the claim. So I will end my discussion for tonight's meeting on this slide. I will be uploading the whole chapter in our Google Classroom stream for a repetition. And then I'm going to upload also the recorded part of this discussion in my YouTube channel. I'm going to share that one for review of the discussion of tonight's meeting. Just for a moment.